4th day you can obtain the plastic part. Means hardly within a week you can get product once you have the concept, once you design the concept, once you obtain the solid model, then final product you can get within a week. But think about just the plastic molding industries who requires a die, uh, that ordering the die and getting that die ready, it takes 3 months and more, 3 months. This is possible in say 4 or 5 days, and there it takes the months. So this way the lead time is substantially reduced by using rapid prototyping for development of the rapid toolings. Plastic die making. Now this is again the component and negative of this component. This is the solid model for that, and ABS component was fabricated by using this RP technology, that is fused deposition modeling technology. And since this was used as a die to fabricate the wax patterns, again, since it is manufactured layer by layer and there are the stair stepping effects, and then the liquid can entrap on this, some metal deposition was performed. But this metal deposition, that is metallizing of plastic parts, it is quite not possible in these 3D printed parts because of the porosity. And when you want to metallize these plastic parts, some chemical treatment of the surfaces is required. And when these components are deep into the uh, chemicals, then chemicals get entrapped in the these products, and then you cannot have say metallizing on this. But there are some other techniques also nowadays which can be used if you want to metallize. Basically, the surface finish of this 3D printed part is the problem. If you could improve that, the better surface finish, if you could get, then definitely number of problems can be solved using this technology uh, in development of the rapid toolings. So wax patterns can be produced by using the ABS die. Now this ABS material which is used to fabricate die, that is the plastic die, by using the 3D printers, can be used to produce the wax patterns. Some attempts uh, failed because of the depth of the component. So these were the two parts of the dies, and this depth was say very high, of the order of say 15 mm and all that. So it could not sustain. Then it was split into three halves, and one over the other when where those put it was possible. These are the wax patterns which can be fabricated. Not only this, the beauty is that this gating system also, riser also you can have welded in one setup. There is no requirement of the separately welding gating system and riser, all that. So that is possible. Comparison of this rapid prototyping patterns with wood and metal. If we compare as far as on various grounds, uh, the ABS RP patterns are better. But again, there are some advantages of metal patterns, some advantages of say ABS patterns, and some advantages of wood patterns, because wood patterns are the cheaper one. The metal patterns are say life longer, and overall performance either cost wise or say performance wise, ABS are the better patterns. So this is the some dimensional analysis on the basis of which the performance can be measured. As far as this cost is concerned, the wood is lowest one, and this metal is say you can say the highest, because the metal say patterns cannot be fabricated uh, manually. Otherwise, it will require a number of processes and all that. But by using a CNC, you can say fabricate it. And when a single component is fabricated on CNC, again, it cost goes very high. So in that sense, CNC fabricated this pattern, metal pattern, which is used conventionally in the industries, that will cost more than the RP. And lead time is the lowest in case of these RP patterns. If you go for the RP tooling, the lead time will be lowest. Delivery you can give very fast for the toolings. And unit cost, when the thousands of components need to be fabricated, then definitely the metal pattern will be advisable. In that case, we cannot say suggest the ABS patterns or ABS toolings. And wood is the costlier one. No, wood, no, wood is not costlier. Wood is the say cheaper one. Variations in metrological aspects. As far as various features of any products are concerned, that is concentricity, then flatness, taper angle, circularity, everywhere the quality of this ABS tuning will be better or found to be better. Challenges of this rapid prototyping technology, the creation of natural forms. Now, here some forms are shown, which are the which are from nature, and these are such a forms that you cannot have sketch of it. You cannot have say CAD model of it. Uh, Either you, even if you use say reverse engineering, some 3D scanner, you'll have to put a lot of effort while editing the CAD file. When such a shapes are there, building is not difficult with the 3D printer or this RP technology. The difficulty is getting the CAD model of it. And this is the biggest challenge, how to create a CAD model for such a shapes which are unique. Then data transfer in CAD system is the basic problem, because in this everything is automated. When you create some drawing by using some dimensions, by using some high-end graphics package, and then the STL file is created on behalf of that CAD package itself. There is no intervention of human being that improve this curvature, improve this dimension and all that. And that is sent to pre-processing software. Again, that is the automated process, that is tool generation is automated. Only you can set what is the accuracy level and all that, and what should be the build orientation, whether you want to fabricate it horizontally, vertically, or by offering some tilting angle. So only these are the things you can control, but everything is automated. So when CAD data is transferred for actual building by the 3D modeler, nobody knows that what will be the changes, because CAD model itself, when shown on the computer screen, and when some algorithms are used to develop some curvatures, some circles, and some say cuboids and all the geometry, it use some algorithms, and what it is using, what it is representing at on computer screen, and what is the resolution of the computer, uh, and what is transferred. So everything is virtual. So this need to be say studied or highlighted. So, or that is the problem. Then this tessellation and slicing, this is also the automated process. The computer software takes care of it, and there is no as such alternative for these things uh, to change. And if anybody wants to alternate all these things, then he will have to work at algorithm level. And there are the algorithms which were developed by the basic mathematicians. They are still in use, and that is again the scope. Fast acquisition, fast acquisition and transformation of model data. So what happens? This CAD model, when we build, uh, the file size will be huge, and when that file size is transformed to 3D modeler, when it acquire the STL file, and then it regenerates the toolpath. That toolpath regeneration takes a lot of time. Uh, that is called as the pre-processing. So that time needs to be compressed, the pre-processing time, because it depends upon what is the size of the CAD model, and if there are the intricacies, and uh, what is the say problem with this, when we are tried to feed the data of one of the cancer patient, one of the dentist doctor, he wanted he provided this DICOM file of cancer patient, and the cancer patient was such that uh, his chin was completely say destroyed because of the cancer cells, and he wanted to remove that. So he had uh, this CT scan file, and he handed over to me that CT scan file. And when we obtained the solid model, and when that STL file was given to 3D modeler, so those porosity, actually that bone has to be cut and thrown away, which was diseased one. But this 3D model accepted that diseased one, the porosity, a lot of distortions in the bone as the model, and it was showing some more than 20 hours to build that. So this happens if versatility or some flexibility is not given to the user. Then control of this cusp height or stair stepping effect. This is also the problem, and of course it depends upon the modeler that how much accuracy it permits the user to develop. And there are the limitations of modelers that they cannot go beyond that. Means whenever that is surface finish is the problem uh, as a gross in this 3D printing technology. Then the problems associated with layer thickness, road width, and air gaps between the road widths. So these are the limitations. Means these are the fix, and nobody can control it. As a user, if you want to say work upon this, then that is not possible. The flexibility is not given. Uh, everything. These are the patented things, and one can work upon this at modular level. How you will say deal with all these parameters, and if you could change these parameters, then definitely there will be the improvement in the models developed by using this RP technology, and better toolings can be produced. Then part accuracy problems are there, that is at mathematical level, then process related and material related. In process related, the speed is fixed, cycle time is fixed, then limitation for the miniature parts, micro features, that those are the limitations, and then other performance parameters we can control. And as far as material is concerned, this ABS materials which we discuss for patterns, there is a problem of say it is a hygroscopic material. It is sensitive uh, for the weather, so environment can affect on that. Important issues related with tooling and manufacturing. None of the rapid prototyping technologies yet produce models in materials that are suited for production tooling. Now, in conventional, what we see, these production toolings are very, say, uh, you can say accurate also, you can say lifelong also. But with this rapid prototyping technology, by using, say, metal technology, in which particularly powder sintering method is used, or metal RP technologies are used, the products that we get, those are not, say, competitive as compared to this production tooling which are available. Then RP provides solution, but are limited by high cost and installation and maintenance. As far as this technology, the quality you want in the modelers, because there are modelers which are available in the market. You can get it for 20,000 rupees, and you can also get it for say 50 lakhs rupees also. And metal, you can get it for say 4 to 6 crores also. And bioplotters you can get for say 1.5 or 2 crores. So that depends upon what quality we select. So that's why the cost of this technology is really high. And then after sales maintenance also it requires, because since all the technologies are patented, the materials are also cost. These we already discussed, that is thin wall geometry is not possible, and accuracy, strength, delamination are some of the problems of this. This build orientation issues in the is the again need attention, because the every product there are options how to build, whether horizontally, vertically, or by tilting. A number of possibilities are there. You can rotate it by 360 degrees, and at any degree you can build. At this technology can build, because rapid prototyping technology don't require any, say,